All right, solving polynomial equations. I'm going to review some geometrical shapes. We need these shapes to be able to solve some of the problems in this unit and the upcoming unit. So we're just going to spend some time reviewing the geometrical shapes. For example, this shape is known as the cylinder. The cylinder's volume is essentially the area of a circle, which is pi r squared, and we take that pi r squared and multiply it by the stretch of the height. And then we have a cone, which is essentially a cylinder that's been squashed at one end, and that is the volume of that is equal to the same volume as a cylinder, and then you take this cone and divide it by 3. Then we have the shape of a rectangular prism. This rectangular prism is basically the area of a rectangle, which is length times width, and we multiply that by a stretch of a height. So you notice that all of these shapes have a similar concept, and that concept being the fact that they originate from a 2D figure. So again, if we're looking at this, a cylinder is the area of a circle times a stretch. The area of a cone is a cylinder times the stretch up the middle divided by 3 to be very similar to what you saw in the cylinder. And then the area of a rectangular prism is the area of a rectangle, which is this part down here, multiplied by the stretch. All right, let's look at a few more. We have a square-based pyramid, and the volume of a square-based pyramid is basically the area of a square, which you guys know is length times length, or length times width, but width is the same length, so length times length, which is length squared, times the stretch, divided by 3 to create that point. And last but not least, the volume of a sphere is going to be 4 pi r cubed divided by 3. So these 3 in particular are the ones that are divided by 3 because they originate from a particular shape that does something weird. In these cases, they come up to a point, from their base to a point. And in this case, it's like a circle that's been rotated all over the place to create this ball shape, so spherical shape. And they're all divided by 3. All right, next. Example number 1. You determine the possible values for the radius if volume is equal to 684 pi meters cubed. So we have a cylindrical shape, and all you know is that the height of that cylindrical shape is 15 meters. The radius is what we don't know. And as you know, the radius, and this is a cylinder with a cone on top. So if you can imagine, you've got the cylinder shape and with half a sphere on top, not a cone, sorry, but half a sphere on top. All right. So the volume of a sphere, or half a sphere, is 4/3 pi r cubed times a half, because it's half a sphere. And the volume of a cylinder is pi r squared times the height, which is 15. So the volume of the total objects together is 684 pi, and that has to equal 2 pi r cubed plus 15 pi r squared. Now you're wondering, why is it 2 pi r cubed? Let's go back here. This is going to be 4 times 1. This is going to be 2 times 3, which is 6. 4 over 6 gives us 2/3. And if we look, remind us again, here's an example. You multiply the numerators, multiply the denominators, and that's how we got 2/3 pi r cubed. Next, you're going to move everything to one side, just like we did here. And why are we doing this? Well, folks, what we can do now is solve for this polynomial equation. We solve by first taking out a common factor. What we did is we took out the common factor of 1/3, just so that the fraction disappears. We also took out pi, because pi exists in every single piece. Once we do that, looking at the inside here, we can factor this. Now, to factor this, I know it might take you a little longer to do it, but basically it should be some relatively nice number. Turns out to be 6 works out using the remainder theorem. So r minus 6, which we're just choosing just the minus 6. Remember that synthetic division. We write the factor there, which is r minus 6. We get rid of the variable, and we fill in the numbers that corresponds to each variable. This was a cubic, so therefore we must have 4 terms. 2 is the r cubed, 4 is the r squared, 45 is the r squared, 0 is the r, and the constant was negative 205. And, negative 2052. And then we multiply and add the values, or subtract the values, we get the remainder equals 0. And now I want you to notice something really neat about how to do synthetic division. So, what we can do automatically is put a minus beside everything. So we're just going to put a little minus in each thing because we know we have to subtract each of these values. And as we add them in, so we're going to add another minus. Well, if we're adding another minus, we can automatically change that minus to a plus. Okay, and we can continue it, plus 12. So negative 6 times 2 is negative 12. So 45 plus 12 is going to give us 57. Then again, negative 6 times 57 is negative, so we change that to a positive now. 342, and that gives us a value of 342. Next one, we got another minus there, so we're going to change it to a plus and bring the number in, 2052, and that gives us 0. What does that 0 mean? Well, 0 is our remainder, right? And what does that mean? Well, it means that, therefore, r minus 6 is a factor. So that we stay consistent from earlier before, when we saw the r minus 6 here, and because we got 0 here, that means that r minus 6 is a factor. That's the only time it could be a factor, is if the remainder is 0 in the very last column. Now, we're left with 2, 57, and 342. All right, now, I want you to think about this just a little bit carefully. Do we need to continue factoring this particular question? Well, if you know anything about factoring, if you remember about factoring, what will these kind of answers yield? Well, if it was factorable, you would have the following. You would have a r minus 6 still, so when this is just, you would still have the r minus 6, but in the other ones you're going to have 2r plus something and r plus something. Do either of these values give us an answer that we can use? Think about it. Well, hopefully you remember that both of these will yield to r equals a negative value. What is r essentially? Remember, in the whole function, r was the radius. So these will actually end up with answers that are not possible or not required for us. And if some of you think about it as extraneous roots, they're extras that we don't need, so we can take those out. So that means that, essentially, everyone, what we have here is this is our final answer. This here is our final answer. The only possibility for this statement to be true is that, is that the radius must be 6 meters. And notice here again, I wrote the note here, this will only have negative r values, so therefore it's not required, and it's not a possible answer for our solution. So the radius of that cylinder with the cone on top must be 6 meters total. All right. Next, we have a question here that talks about the paths of 2 orcas. And these orcas are playing in the ocean, and they were recorded by some oceanographers. The first orca's path could be modeled by the equation h at t is equal to t to the 2t to the power 4, and so on. And the second orca is this path, where h is their height above or below the water's surface in centimeters, and t is the time during the first 8 seconds of play. Over this 8-second period, at what times were the two orcas at the same height or depth? What's important to note, at the t values can only be between 0 and 8. So what we do is set the equations equal to each other. Once we do that, we can collect like terms. Move everything to one side so that you have a positive t to the 4 and it equals 0 once you collect the like terms. So the possible values of t to 8 is plus or minus plus 1, plus 2, plus 3, plus 4. Notice there's no minus there. It's not plus or minus. It's only the positive values. So 1, 2, 3, 4, 6, 8, and then divided by 2 for some of the values. So those are the only possible values. We move on to the next part. Remember that we're going to try t minus 4, so we get rid of the t, and we use synthetic division. All right, and we're going to go through it step by step. 2, and remember that we're going to put a negative in each of these columns. Negative, 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 and in case we need to change it, we can change it right away. So there's a negative. So this will result in a negative, so we want to make it positive. There we go. Positive 8. And put that together, gives us negative 29. Then when you negative 4 times negative 29 gives us a positive number. Subtract those values, or put them together, is 111. Multiply that, and that will result in a negative value, so we want to change that negative to a positive now. And that gives us negative 552 plus 444, and that gives us negative 108. Multiply two values, that gives us a positive value. So we add those values together, we get 0. Remember what this means, folks. That means that x minus 4 is a factor. So you can write that in here. X minus 4 is a factor. Okay, and we try it again. We try and factor again. And it's x minus 4 is a factor because 0 is the remainder. And we do synthetic division again. And this is what we get. Okay. And that means that x minus 4, because the remainder equals 0, x minus 4 is a factor again. And what that will yield us is a quadratic. So we have t minus 4 squared. Oh, let's rechange those x's to a t because it's true. It is t minus 4 is a factor. So let's redo that again. Redo it again. So this is the remainder. So t minus 4 is a factor. And finally, for this one again, so t minus 4 is remains another factor. So there are two t minus 4 factors. So when we write it out, we have t minus 4 all squared times 2t squared plus minus 21t plus 27 equals 0. Ultimately, what that gives us is different factors. The only possible values that where the seconds are the same is at 4 seconds and 1.5 seconds. All right, folks, that's the end of the video. Take care.